Okay, hello everyone. Welcome to lecture 4 of Ops and welcome to the start of winter quarter.
You guys can find our slides up here, tinyurl ops 2021 lecture 4 if you guys want to follow along there. Otherwise, I guess we're ready to get started.
Yeah, we have a few quick announcements to make before we get started. First of all is with the new quarter comes new lab hours. So last quarter was kind of Wednesday was the big ops day where we were all in there. Now it's looking like it's going to be Thursday. Yeah, me and Margot all have our hours on Thursday. Also, since the first 2 weeks are virtual, the physical lab is closed for the first 2 weeks, and instead it's going to be in the IEEE Discord. So there's a voice channel that says lab, and you can find officers in there. So if you want to work on your project, come in, just ask a question, just hang out. Yeah, just drop in to the Discord chat. Appreciate you doing that because sometimes it gets real quiet when you guys don't join. Yeah.
And none of the officers are going to bite. They're really kind. So if you have any questions or if there are any officers that you want to get to know more about what their position is or what they do, then feel free to drop by during their Discord hours. Next thing, in terms of your parts pickup, we are going to be releasing your newest project, and it's going to be released on over the weekend. That way you guys have some time to read over it. But in order to get your parts, you're going to have to come to the actual lab. If for some reason that doesn't work for you, please message us individually and we'll try to figure something out for you. But you're going to be getting a kit of a couple of things: your jumper wires, your Arduino Nano photoresistors, and just regular resistors and an LED to, again, get started on your next project.
So next announcement is that the Idea Hacks sign up deadline has been extended to this Sunday, which is the 9th. And Idea Hacks is the largest hardware hackathon on all of the West Coast. You get to build an entire hardware project in one weekend, design and build your own project, work with your friends on a team, learn new concepts, use new parts, network with industry representatives. It looks great on your resume. And honestly, it's the most fun part of IEEE. I did this last year and I had the best time. It was literally so fun. It is going to be virtual this year because of COVID stuff, but that's not, it was virtual last year and it was still amazing. So seriously recommend you guys signing up. I seriously, it's so much fun and just a great experience. Yeah, so you can visit ideahacks.la is the website, and it has more information and the application there. So yeah.
Now, I know it's been a while since we did any sort of ops concept stuff, but I did have a couple of questions, and anybody who can answer can get some extra lab bucks. So feel free to either raise your hand or type in the chat. The first question is, what is a capacitor and how does it work? Anyone wants to raise their hand or? And it's okay if you don't have like the entire answer. Maybe what is a capacitor? Does anyone know about that?
Okay, I see stores charge in chat. Work like a switch. Not quite that one.
Parallel plate separated by a dielectric material stores charge. Nice.
Oh yes, very physics answer. Love it.
Yeah.
Yeah, looks like a lot of you are remembering. Awesome.
So Ingrid, you did answer first. So we'll get you some extra lab bucks for that. And then I guess somebody else answered in the chat. It works by slowly charging and quickly discharging because it's separated by a dielectric material. So nice. Honor roll. That's also, I'm gonna also get you some lab bucks there.
Awesome. Also about lab bucks, we're still working on getting some of the lab bucks in from last quarter. So be patient, and that's coming soon. Okay, next, integrated circuits. Why would you use an integrated circuit? Does anyone know? Anyone want to type in chat? Maybe even unmute. That would be insane.
It's compact and cheap. Nice, Kevin.
Nice.
Okay. Okay, yeah, it's pretty much, it's compact, it's cheap, and yeah. And also it's really nice because, yeah, it has a lot of components that makes it simple. What's nice about it is that you can think of it like a black box. You have just your inputs that you have to deal with, and you get some outputs. Yeah, exactly, Liam. Nice. Okay, so Liam and Kevin and Tiffany all get some points.
Okay, also, and then the last one, what are some applications of 555 timer?
Flashing light. Nice, Miriam. Our
Ralph's
ops
project,
project.
of course. That's all they're used for, I'm pretty sure.
Pianos. Yeah.
Yeah, right along. Yeah, basically anything where you're using timing applications. Yeah, you could even use it to make a clock for a computer. Yeah, 555 timer, very useful. Okay, so let's get into what we're going to be working on this time on UPS.
Okay, so for this lecture, we're going to be walking you guys through the Arduino platform and how to set up your computer to have the IDE software to be able to code using your Nano. We're also going to be talking about some of the coding basics, voltage dividers, and we're also going to be talking about a little bit about your project itself.
Awesome. So let's start with talking about microcontrollers. So what is a microcontroller? Well, it's basically an integrated circuit that's like an entire programmable computer. And you can see there's a bunch of pictures of a bunch of different microcontrollers on here. They come in a lot of different shapes and sizes. Some are just the chip themselves. Some are like on whole boards that you use. And yeah, and they all have inputs and outputs, which is what you're focusing on. So they act like a black box also, but they allow us to program and like actually get stuff done with our circuits. And yeah, they're awesome.
So we are going to be working with the Arduino Nano, which looks exactly like this. The nice thing about it is that it's really beginner friendly because it doesn't have a lot of parts to it. It also is really small and compact. It easily fits into the breadboard and it has a 5-volt operating voltage. And then it has a mini B USB port and an AT 328 chip.
Awesome. So when we're working with microcontrollers, what we want to look at is the pin out of the microcontroller. And so you can see on this picture here, it shows us what each of the pins do on the microcontroller. And so with those pins, you can do really anything with this microcontroller. You can read in temperature values as an example of input. You can turn a fan on as an example of output, control an autonomous car, and so much more. So the pin out is really helpful as it will tell you which pins you're going to use for which things. So if you look at the green here, these are the digital pins. Some of them say digital PWM. We'll talk about what that means later. Analog pin over here on the left are these yellow ones, 3.3 volts, 5 volts, ground, 5 volts. So it's just in the project, you're going to have to connect different things to these pins. So you'll want to come back to the pin out to look and see which pins do what.
Awesome. So in terms of Arduino Nano, there are 3 different types of communication systems or communication signals that we can send out. Preston, if you could go back to the previous slide quickly. Like Preston showed, we have analog signals, we have digital signals, and we also have digital PWM signals. Now if you could go back to the other slide. Yeah, so with an analog signal, this type of pin can only read in values. So it is an input only pin. And that's really important when we start to program because you don't want to be trying to use this analog pin to do something because all it can do is read in values. So again, it's denoted with an A and then a number. So you have A0 through A9 or whatever the pin layout is for the Nano. And again, with analog, you can kind of think of it as a continuous signal. It's pretty much everything in real life from time to, you can think of it as like your actual life. You know, you were born and then you continued on this path through life. That is how you can think of an analog signal. And then we also have on the flip side of it, a digital signal, which is only used obviously for technology. You have zeros and ones, and digital signals are really nice because they can take inputs and they can be output pins. So they have multiple functions. However, you can't send values in between. You can only send an on or off value. So there are, So it's kind of difficult to be able to take an analog signal, like something from the outside, and then send it to your computer, because your computer can only understand ons and offs, while the outside world has continuous functions that are discrete values. And so that's the reason why we also have PWM signals, which is kind of like a way to convert analog signals to digital signals. So to be able to take something from the outside and give it to your computer, you have to use a PWM signal. And a PWM signal is a pulse width modulation. And again, it turns a digital signal into an analog one. And you can essentially do that by adjusting the duty cycle, or basically the amount of time that the signal is on or off. So you can adjust the duty cycle to be 50%, 75%, or 25%. And this all just changes the frequency. And so with PWM signals, you can have ranges from 0 to 255, as opposed to just 0 and 1. And then in order to use these PWM signals, there's actually going to be a tilde sign right next to the digital pin, and that indicates that it can also be used as a PWM signal. Yeah. Are there any questions about the difference between analog, digital, or PWM? I know it's a little bit confusing to understand why we would even need PWM signals. So if there are any questions at all, I'm more than happy to go over that.
Any questions?
Okay, cool.
Okay, can you guys give a thumbs up if you're good? Yeah. Nice.
Awesome.
Nice.
Okay.
Awesome. Okay. So now we're going to go on to a little bit of coding. So we've spent a lot of time with hardware now with the circuits that we've made. And so now we're going to use our microcontroller, which will allow us to actually program it. And as you can see, we have an example of what it looks like to program it. And that's the software is called the Arduino IDE, which will allow us to program our nanos and do whatever logic we tell it to.
So you guys can follow along and download the Arduino software right now, or you can just do this on your own time. But the first step to be able to communicate using your Arduino Nano is to download this Arduino software. And you're going to choose the operating system that you obviously use and just follow the steps there to be able to download the IDE. And the IDE is where we are going to code and send all of the information and the basic instructions for the Arduino Nano so that I can eventually do it on our breadboards.
Also, just so you guys know, there's now like 2 downloads for this on their website. There's one that's like an experimental version called Arduino IDE 2.0. We don't recommend that you use that one, especially if you're a beginner. We recommend that you just use the standard Arduino IDE one because we haven't really used the newer one, so we can't help you with the problems. But yeah, it'll be pretty clear which is which. It's just it'll say 2.0 if it's the newer one, but you just want to download this one, Arduino IDE. So yeah, sorry.
Oh, sorry, go ahead, my bad.
Okay. So when we get started with our sketch, the first thing that we're want to do when we open up our Arduino software is we want to open a new sketch. And a sketch is basically like the page of code that we're writing for it. So you want to go to File and then New Sketch. I don't know why that, okay. And then now we're going to take a look at what all the different buttons do. So that button right there, which is a little check mark, that will compile your code. And what that means is it basically reads through the code that you've written and check that everything works and that it's going to work and that the computer knows what it's trying to do. So if it fails to compile, you'll get like a red error and it will tell you what mistakes you made and like where in your code you should look to check and try to fix them. Next, this one right here. Compiles and builds your program, which sends it directly to your Arduino Nano. And then it will start working. So this right here is where all your code goes in the little white space. And yeah, so Arduino uses C++ to code, and it has its own built-in functions that it uses. So just in case you guys haven't been introduced to coding before or programming, we're going to go over just a basic introduction to some of the C++ stuff. If you've programmed before, some of this might be a little repetitive and slow, but we just want to make sure that if anyone hasn't done any programming before, that they're not completely lost. So the first part of programming is variables. And variables allow you to store information in your code, and they can store numbers, letters, sentences, and so much more. So you declare a variable by typing the type of the variable and then whatever name you want to give it. And then you give it a value, so equals value. And there's a bunch of different types. So the first one is int, which is an integer number, which means that it's not a decimal. So for instance, int myint equals 42. Then we have float, which is a decimal number. So we have float pi equals 3.1415. Then we have char, which is a character, which means like basically any letter or number that you can type on your keyboard is going to be a character. And so we have char, my char equals a. And then we have a string, which is a collection of characters, which here we have string message equals hello world. So we can use this to write text in our program. And then finally, we have a bool, which stands for Boolean value, and it means either true or false. So this is going to be really helpful for logic when we want to do certain things. We want to know if something's just like either one thing or the other, if it's either true or false. So for instance, we have bool is lecture over equals false. And then next, what we want to, now that we have our variables, we want to be able to do stuff to them. And that's where operators come in. So arithmetic operators are basically just normal math things. So it basically just looks like math equations and pretty much acts the same way. So we have addition, which is just plus, subtraction, which is minus, and then multiplication, which is the star sign on your keyboard, and then division, which is the little slash. So we have examples of each of those there. Those are pretty simple to understand, as it's just like basic math. Just the program basically becomes a little calculator when you use these. Next, we have comparison operators. So these are going to compare two values, and it's going to output true or false with them, which we'll see why this is helpful later. But the first one we have is not equal, which is an exclamation point and then equal sign. And it just means not equal to. So if we have my bool equals 1 and then not equal to 2, it's going to output true because 1 is not equal to true, if that makes sense. Also, these two slashes here that I wrote, that's how you can comment in your code, which means anything you write, anything you type after doing 2 slashes won't be interpreted as code. It just allows you to leave little messages and reminders for yourself, which will be very helpful as you code. You want to do this to make sure your code is readable and you know what you're doing when you're looking back at it later. Next, we have equal sign, which means equal to. So my bool equals 1 equals 2. This would output false, basically, because 1 is not equal to 2. So it's false. Then we have greater than or less than, which is pretty much makes sense. And then greater than or equal to, and then less than or equal to, which also is pretty much what you would expect from them. And then finally, we have Boolean operators. And so these operate on Boolean values, which are, again, the true or false values. So if you do not true, so not is the exclamation point, it's called logical not. So if you do not true, it will be false. If you do not false, it will be true. Then these symbols are called ampersands. If you put 2 of them in a row to 2 Boolean values, it will only output true if both of them are true. So if you do true and true, then it would be true. But if you do true and false or false and false, then it's going to be false. And finally, we have the OR operator, which is 2 like vertical bars. I think on your keyboard, it's the one like underneath one of the slashes, but it's just like a vertical bar. And this is logical OR. So we'll output true if either of the bools is false. So if you have true or false, it will be true. Or if you have false or false, it will be false. And true or true would also be true. And yeah, those are the basic operators which allow us to operate on variables and do stuff.
A couple of other things in terms of the Arduino syntax. Again, we're working in C++, so a lot of the rules still do apply. After every single statement you make, you always have to place a semicolon. So for example, if you were trying to print something to the serial monitor, which we'll talk about more later, we'd write serial.println. Ops kids are the best because they are. And then you always want to put this semicolon after your statement. Otherwise, your code will not compile. And then another one that is always helpful, especially in a lot of the ops projects that we're doing right now, is an if-else structure. It essentially says if something is true, or if this particular equation evaluates to true, then you have to do this. Otherwise, you have to do something else. And it looks something like this. If an analog pin is equal to 1023, then you can write the digital pin to high, or else you have to turn it off.
Yeah, so this is where those comparison operators are going to come in handy. You're going to often be comparing values, and that's why we want to output the Boolean value of true or false for those. Also, you don't always need to use else statements at the end. Sometimes you just want to use an if. Basically, you can change it up depending on the situation.
Yeah. And one thing that I find a lot of ops kids do tend to struggle with is they run into problems where they say, if the analog pin is equal to 1023, you have to put the double equal signs. Otherwise, you're essentially just assigning that a variable to be 1023. And so therefore that if statement would always run, as opposed to just checking to make sure that it's 1000.
Whenever you're using equals as a comparison, you have to put two equal signs. It's super important. Yeah. Also, you don't, shown here, we just have one statement for each of the if and else things, like digital write. We have only one thing that you can do after the if, but in reality, you can put as many lines of code as you want after this. So you could have if analog pin equals 1023, you could do digital write, then delay this, then do something else, then do something else, and then go on to the else. You don't have to put only one statement. So this is super helpful, as we can have logic, which can then, based upon inputs that we're getting from the real world, this will allow us, our code, to actually do things depending on the values we get, which is, that's where this really starts to come together.
Okay, so now we're talking about the actual code. In terms of Arduino's code, there are two important functions that you always have to have, which is void setup. That's the first one. And then you also have a void loop. So void setup runs once at the beginning of each build. So it only runs one time, as opposed to void loop, which we'll talk about later. And generally, we use void setup to initialize variables and pin modes. And pin modes, we'll talk, pin modes are essentially setting a pin to input or output. And this can only be done for digital pins, because can anyone answer, is an analog pin an input or output? You can put in the chat, or you can just, nice, Tiffany. Okay, awesome. So nice. Tiffany was right. It is an input only pin. So therefore we wouldn't have to worry about this pin mode function when dealing with analog pins. And then you can also start the print to serial monitor. Now I'm going to do kind of like a hand wave motion here and say, just whenever you want to use serial monitor, write serial.print, a serial.begin 9600. Always put 9600. And again, I'm doing a hand wave motion. We'll go more over why you use 9600 next quarter. But this is the line of code that you need in order to be able to read anything from the serial monitor. A couple of helpful functions. We already talked about pin mode. You need the pin number and then whether or not you want it to be an input or an output. And it sets a pin to receive or transmit information, which again is only for digital pins. And then serial begin, where you always use 9600. So that's pretty much the only things that you guys will ever have to worry about with the void setup function.
Yeah, or just anything. Sometimes for whatever code you're trying to do, you'll want something to happen only once. Mm-hmm. So sometimes if you ever want to put something that you want to happen in your code, but only happen once, you'd put it in setup. Also, these will always, whenever you make a sketch, it will already put void setup and void loop automatically in there. So you don't have to worry about of doing that. It'll do it for you, but yeah.
I did have a question here. What happens if we use something other than 9600 when we write serial.begin? Essentially, your serial monitor is not going to work because you're not sending rates at the correct baud rate that the serial monitor is expecting. And again, we'll go over more about what baud rate is, what 9600 is. But if you don't write 9600, you're not going to be able, your serial monitor isn't going to work.
Yeah, you can configure it to do other ones, but in this case, it's best to do 9600. That's what the Nano is expecting and using. Yeah, you basically, for our purposes, we don't really need to change it ever. And then next we have void loop. So void loop, as opposed to void setup, will run repeatedly throughout the function. Your code basically will run over and over again on the processor. So the way it works is that it will go through setup first, and then it will run through each line that you've written in the loop. And then once it gets to this last line, it will immediately start at the top again and read through them. So basically we want to put all the stuff we want our circuits to do in the void loop portion of the code. So some of the helpful functions that we want to have here would be if we want to use digital write to set a pin to 0 or 1, on or off, turn on or off an LED, change a fan, whatever, we would want to use digital write. And then analog write with a pin and then a 0 through a 255 value. We would want to use a PWM pin because those can generate a continuous signal, which means that it's not just 1 or 0. It's like it can be any value between 0 or 255. And then also analog read. So if we want to read something that, if we want to read something from a pin, see what voltage is at that pin, it will return a value between 0 to 1023. So digital write and analog write don't return anything because you're like sending something out rather than trying to get something. So they don't return anything, but analog read will return whatever value is at that pin. Yeah, which then you can save to a variable. So for instance, if you want to do like int myint equals analog read pin A5, you could do that and it would then like save it. And yeah, so void loop, that's where basically all the work happens.
All right, so I have a question for somebody. It would work best if they like unmuted and answered the question. But what do you think this this code does essentially? And if you don't feel comfortable unmuting, that's totally fine. You can just type in the chat as well.
Any brave souls?
Okay, Tiffany says flash a light, and that's okay, Tiffany. So it's flashing a light. Do you think that okay, yeah, exactly. It's flashing. And how did you know that it was flashing a light as opposed to just turning it on?
Yes.
Okay.
It turns on and off. So she saw that because it says digital write LED high, so that's turning it on. And then it waits, that's what the delay function does. And then she saw that it said digital write LED low, which would be turning it off. So that's what she got at when she said it turns on and off. That's what's happening. But yeah, so this is a very basic example of what you would want to do with your code.
Awesome. So one thing that you can do is when declaring pins and variables, you can declare them as global variables. And these are variables that are declared outside of the void setup and outside of the void loop, and they can be used all throughout the program. So if, for example, we were just trying to make a light blink on and off, we wanted to use that LED pin. Let's say we said it was pin 13. We wanted to use that pin throughout the entire program. We can declare it as a global variable. So the entire program can use this LED, and it'll know it to be LED is equal to 13. And it's always good practice to declare pins as global variables. That way all your sketches functions can use them. And then I have a question, again, if anybody is willing to answer in the chat or by unmuting. If I used LED in the setup or loop function, what would it mean?
"13, awesome. Thank you, Jonathan.
Yeah, exactly.
Yes, 13, great job. Okay, so here's some other useful built-in functions. So here we have serial.print x or serial.println x. So these were ones that you saw we used earlier because they're probably the most helpful for if we ever want to write something or write something to debug. This is what we use. So it prints things to the serial monitor, and serial monitor is like kind of a confusing term. It just means like a little text box that comes up and outputs text basically that you're writing to it. That's all the serial monitor is. In order for serial.print to work, you need to write serial.begin 9600 in void setup. And they both do the same thing, but print line adds an extra line afterwards, basically like a return. If you were to hit enter on a keyboard, it will like enter a line down. So if you only use serial.print, it will like print everything on the same line, which is generally not what you want if you want to print out a bunch of things. generally you want to have a line go after it. So the next thing goes down on the next line. So that's why you would use print line over print. And yeah, just examples, serial.print. This lecture is super long. Unhappy face, serial.print line. I know these guys just keep talking. Oh my gosh. And now we have digital read pin. So this is like we talked about earlier, this will allow us to read input from a digital pin, which means that it will only read high or low. And it will then return high or low, which is what's at that pin. So if we were to do int x equals digital read LED and then serial.print x, it would print out whatever is at the pin LED. Yeah. And then also we have delay. This is a super helpful one. This pauses a program for a certain amount of time, and the unit setter it's in is in milliseconds. So for instance, if we were to do delay 1,000, how many seconds would this pause the program? Does anyone know? Can anyone convert? 1 second. Nice. Okay, we have a question in the chat. So we have, just to be sure, writing int LED equals 13 above in setup and loop sections. Okay, so he's talking about in this one, assigns the 13th pin to the LED variable. While doing that definition inside any other function, it finds the value of 13th LED variable while doing that. So basically, if you assign it outside of void setup or loop, in void setup and in void loop, it will always be 13. But if you were to only do int LED equals 13 inside of setup, then if you try to go to loop and you try to say like LED, if you just were to print out LED, it wouldn't know what to do because it doesn't print, LED wasn't created here. It was created inside of setup. So it doesn't know about it. So you want to put them outside of setup or loop.
Sorry, I just wanted to say, you can declare variables inside setup and that'll be fine. It's just like, for example, if you had two functions here, void loop, and then another function, int add numbers, and you declared a variable inside int add numbers, then the void loop function could not use that variable. That would be the issue. So you don't really have to worry about it right now, especially as we begin we are just beginning programming with the Arduino, but global variables can be used throughout the program. And if you put something into void setup, then it could also be used in the void loop function. But if, for example, you were to declare a variable inside another function, like another function that added numbers, then any other function could not use it. Does that make sense?
Okay. Cool. Okay. Finally, we have, if you ever got lost through this or you want to know a specific Arduino function or whatever, if you forgot what a bool was, there's a really great website that I have linked here, arduino.cc/reference/en for English. And basically it has all the different functions, variables, different structures that you can use. And it just has a bunch of links to different pages. So you'll click on them and it'll tell you everything you need to know about it. And it will give you examples and more information. So this is a really great website for learning more about Arduino programming and programming in general. It just gives a lot of information. It's very helpful. Highly recommend you visit this. And finally, now we just went over a lot of coding stuff. So does anyone have any questions? How do you stop code from running? So that's a really good question. And the answer is, as long as you give power to your Arduino, it will just keep running. So you can't stop it. There is a button on the Arduino which will reset the code, basically start it again. But once you've uploaded code, it will always run it when it's given power. So if you want to turn it off, you'd have to like unplug it from power, basically. But yeah, that's a really good question. Any other questions? Okay, awesome. Let's move on then.
Okay, so we're going to try and do a light blinking demo. This is more going to be focused on the coding because obviously you guys know how to make an LED light up, right? Because we did project one and everyone passed it. Everyone did fantastic. So we can move on to the next slide now. So let's automate our first project. What we want to do is we want to make a light turn on. We want to pause and then we want to make the light turn off and then just keep on doing this. Now I have a question again, just type in the chat. What do you think would happen if we didn't put a pause after we turned off the light? What would it look like?
What would happen? Type in the chat now. On forever.
Yes, yes.
Okay.
Exactly. We wouldn't see it turn off because without that delay, again, the Arduino code is just going to loop back on and it sees, oh, I got to turn it on again. And so we're never going to see it turn off, which is good. Now we can move on.
Yeah. And in these, the Arduino is super fast. Computers are way faster than humans. So like any line, you'll never know between two lines of code. It does them so fast. Yeah.
All right, so now if we were trying to actually code this, let's go ahead and check out this sample code that I wrote out here. I have declared an int LED is equal to A0. The void setup, I just set the pin mode to equal to pin mode to be an output. And then in my void loop, I have this line of code here. Now, are there any issues with this code? I think it looks good. It would always be off. Nice, Miriam. That's exactly right. So we do have an issue here where I don't have a delay. So essentially this loop is going to look, it's going to turn the LED on for a really quick second, not even we can see it. And then it's going to immediately turn the LED off. And then it's going to keep doing that repeatedly where we never actually see it turn on. So we might think that we burned out the LED when our code is just incorrect. So is that good? Is that it? We just needed to add a delay.
Does anyone see any other problems with this? It's kind of hard to spot, but we'll give you a few more seconds to look and ponder.
You need two delays. Alexander, what did you mean by two delays?
I think that's the same thing we said before. I think.
Oh, okay.
We only have one delay right now.
Yeah. So Lauren, you said something about 9600. We only need to do serial.begin 9600 when we're doing the serial monitor, but we're not trying to look at anything on the serial monitor, so we don't need to worry about that. Salim set LED to 813. Kevin also said A0 isn't an int. So A0, when we say A0, that is referring to the pin number on the actual Arduino Nano. And Honoralp is correct, it's an analog pin. And A0, it says it's an analog pin in this 0 position. And can we use analog pins as output?
Oh,
Okay.
exactly. Yeah. So this wouldn't work because we're trying to output with an analog pin, but analog pigs can't output. So we would never actually be able to send anything to the LED, and we would be like, why isn't it turning on? So that's a big problem. I think we have, yeah. So the analog pins are reading only, so it needs to be changed, and there needs to be a second delay. Awesome. So there we go. That's how we would change it. So see, instead of using an analog pin, we use pin 10 instead, and then we add that second delay, a delay of 5,000 between the two ones. So that's how we would fix our code to make it better. Awesome.
Yeah. And if you were to just copy and paste this code into your Arduino Nano and then run it, you'd see a nice blinking light, which is super awesome. Okay. Now we're going to move on to voltage dividers. I know this seems like a far step from what we were talking about before with microcontrollers, but this is going to have to, this is directly applied to your project. So I wanted to be able to explain voltage dividers to you. And this is also really important when you're doing further circuit analysis. And it's really helpful when you're trying to decompose really difficult circuits into more comprehensive and understandable sections. So essentially what a voltage divider is it's simply two resistors in series. And you're probably thinking that literally doesn't, like, what is the point of understanding or being able to recognize what a voltage divider is if it's just simply two resistors in series? But I do have a couple of questions for you. The first question is, because the resistors are in series, what is the relationship between the two? Can anyone recognize or identify which of Kirchhoff's laws we're going to use to be able to figure out the relationship? Or does anyone remember Kirchhoff's laws? Resistance adds, yeah, it does add. That's, but if we're trying to, so one thing to note when you are thinking about a voltage divider, essentially you want to take the voltage across the second resistance. So KVL, okay, perfect. So Kirchhoff's voltage law, and then somebody says, Utkarsh says it's the second law. What's the second law? Current, okay. The loop. Okay, so essentially we can say that because the resistors are in series, they have the same current running through them. So the current running through this first resistor, R1, is going to be the same current running through R2. And with the voltage divider, we're taking the voltage across R2. So essentially what we can say is we can derive this relationship here where it says that V1 times the resistance R2 divided by the sum of R1 plus R2 is going to be the voltage across R2. And it's basically, you can memorize this equation, or you can go ahead and outside of class or outside of lecture, you can use Kirchhoff's current law and also Kirchhoff's voltage law to be able to derive this formula on your own. But this is going to be really helpful later on in, again, more advanced circuit theory classes when you're trying to kind of decompose difficult circuits. So I do have a quick an analytical question for you guys. So if V1 is equal to 1 and R1 is equal to 10 ohms, R2 is equal to 5 ohms, what is V out?
Does anyone know? Can anyone do the math?
A third. Yeah, exactly. And again, it's really nice because everybody's kind of already done this derivation before. So all you have to do is plug and chug numbers in. You don't really have to think about the reasoning behind it. But I did want to kind of explain the reason why we can get this really nice V1 times R2 over R1 plus R2 equation is because you have the same current running through both resistors.
Awesome.
Okay. And then, oh, Preston, did you want to take this?
Sure. So some applications of voltage dividers, now that we see how they work, is that we can use this to create a variable resistance, which essentially acts as two resistors in series. So if you wanted to have something like a potentiometer that we have on the left, which would then change the resistance of one of the resistors based on something that you move, you'd be able to get a different voltage in the output between the two resistors. And then we would be able to see different values as it's being turned, basically. So this is used in like old volume knobs and radio knobs and old light dimmers, and it's super helpful. And it's how the voltage divider equations can be used to see what we're going to get from that, basically.
All right, moving on to project 4. One last part that we wanted to talk about for project 4 was the photoresistor. And if you could just,
why does it?
This is wrong. It's a photoresistor. Yeah. I mislabeled it. Apologies. It's essentially just a semiconductor that's sensitive to light. There's no orientation with it like a resistor, so you don't have to worry about a positive or negative side, which is nice. And as light increases, the resistance decreases. And you'll be able to use this fundamental idea of how a photoresistor works when you're creating your auto flashlight, which is your project 4. But yeah, I just kind of wanted to give you guys a basic rundown of how what this component is before you guys work with it. Again, your project is going to be released sometime over the weekend, and then you'll be able to pick up all of your parts on Tuesday.
Yeah,
Are there any?
once
Yeah.
once we get the parts, once you guys come in and pick up your parts, then we'll send out the spec so you guys can start working on the project. So yeah,
Yes. So
we'll email Discord.
can I get a hands up if you guys prefer email? Because I can't really tell if you guys like email or Discord. I feel bad for like
Okay, we got
constantly
one.
bombarding people. Okay.
Both.
One,
Yeah.
two.
So we got some people who like email.
Okay, so people like email. Okay. Okay then. Yeah, so we are going to be
We'll
the
probably
project is going to be due in about a week. I can give you guys the exact date here. Give me 1 second. You're going to have definitely enough time to do it, but your project is going to be due on January 20th, and it's going to be released like the 8th or 9th via Discord and through email as well.
Yeah, awesome. So thanks everyone for coming. Does anyone have any more questions before we wrap up? How long is it going to take to finish approximately? This one, I don't know. What would you say, Margot?
I'd say if you can, so we're going to host a work session first off, so you can finish it in like an hour, 2 hours, maybe, if you're really diligent, and we're more than welcome to answer any questions. So we're going to both be figuring out how many jumper wires we can give to everybody. But you won't have to worry about.
Yeah, it should be pretty
parts.
easy. We're going to try to set it up so you just come in and pick. They already have it ready for you.
Yeah. Yeah. So, yeah, does anyone have any questions? Otherwise, thank you so much for coming out. We hope you guys enjoyed this lecture, even if it was through Zoom.
This quarter is going to be awesome, guys. This project is pretty fun, but after this, we have 2 projects in a row, which I think are super fun, and some competitions along with them. I'm especially looking forward to the 3rd project that we're doing this quarter, which is project 5. I designed it myself. I'm super excited. It's going to be super fun. So yeah, I hope you guys stick with us throughout this quarter. We're going to have a good time. Have a good night, everyone. And yeah, good luck on the project.
Thank you.
Bye, you guys.
Bye.
Thanks for coming out.